Lens calibration. In this video, we will talk about lens calibration, which does not use any position tracking information. This could be useful in situations where you don't have a tracking system, or your tracking system only has zoom and focus. Or you could be in a situation where the quality of the tracking system is not good enough. For example, it's not micromillimeter perfect, or maybe you have a small jitter that makes calibration difficult. At the end of this process, you will generate a lens profile, but not an alignment profile. In this example, we're using 3D here, and this is mapped into this camera. But we want to ignore position and rotation, so we're just going to read zoom and focus ranges. Let's switch position and rotate off so that we can reset the camera and it would not be influenced by any incoming tracking data. So now it's like a lens readout system only. Within the camera, we go to Tools and then Calibration. But we don't go for lens and tracking calibration, we just go for lens calibration. The rest of this process is more or less exactly the same as we've shown you in previous calibration videos. We select the media input, as well as the calibration screen. Then we can go and press Capture. Once again, we need to capture the screen from different angles. So let's move the camera to another angle and hit Capture and OK. One of the good things here is we don't have to wait for everything to stabilize because we don't have any tracking data to match to, which can make this process much faster. What we're doing here is panning the camera around to make sure we can see all the surface panels of all the screens and capturing in each different position. We're also trying to make sure that we've seen every single panel from at least 2 different angles to give us a better calibration. As we're going through so many captures here, I'm going to speed the video up to get through all of them quickly. This should be more than enough images for a good calibration. It is possible to do this with less images. We're just taking this many here to make sure the whole LED wall is covered correctly. If we're doing just the lens calibration, 4 images from different angles would be good enough. Now we're done, let's hit the play key and wait for that to process. Once done, you can now see we have the whole screen calibrated. And we have a lens profile for this camera with a single observation with its current zoom and focus value. We cannot double check and prove it because we cannot open the distortion viewer since we do not have tracking information. But we can check all the single observations and see how good the quality of those is. We can also look at all of the steps to see if this is working. In the second tab, we have the distribution, which shows which part of the camera sensor has captured some images with markers. It is a good idea to have markers captured along all the edges and the corners of the camera sensor, as that is where the distortion is usually the greatest. In the third tab is the distortion. Here SP is providing a visual representation of how the distortion looks at the current zoom focus step. The last tab at the bottom is the result, where you can look at some of the numerical values like calculated field of view, distortion K values, center shifts, and the projection error. We do have ways to prove this calibration, which we'll look into in the next video.